I want to illustrate mutating joins in the tidyverse. Let's go back to the flights data. I'm going to read in the airlines data. Notice that we only have two things in that data set. The carrier, which is going to be, well, let's actually look at it. So we have the carrier, which is going to be the abbreviation, and then we have the name of the airline. As always, we should look to see that we have a legitimate key. So I'm going to look at carrier to make sure it only appears once. And it does. Notice when I get the Czech Airlines, there are no rows when I filter on n greater than 1. And so this airlines data, which is a fairly small data set, we could have checked it by hand, but we've checked it officially, and we know that we haven't just accidentally overlooked something. There is a good primary key. Now for this demonstration, let's go ahead and create a narrower version of the flights data. So I'm just going to pull out the variables year to day, hour, origin, the destination, the tail number, and the carrier. So let's read in the flights information, which I notice here that I don't have it reading from the correct spot. So give me a second. There we go. So I'm going to read in the flights information. I'm going to put into flights 2 this smaller data set. So now when I look at flights 2, notice that this is much more manageable. Rather than all those variables, I only have 8 variables here. Okay, so now for the demonstration. The carrier key is unique in the airlines data, so it is the primary key. It is not unique in the flights 2 data because we can obviously have in all those flights, we're going to have carriers providing multiple flights, and therefore the carrier is going to appear more than once. In fact, even the very first 2 rows you see United Airlines are those first 2 flights. And so this is not a primary key in the flights data, but it is in the carrier's data. So what we're going to do is we're going to do a left join in our flights. We're going to left join airlines by carrier. Since I'm piping the flights data in, that's going to be the left side of the data. And left join means keep everything in flights, but from airlines, match by the carrier key, and then put the rest of the stuff that's in airlines into these flights data. So here, if I run this command and now look at flights 2, and notice I didn't even save it. I didn't even save it with this information, but I could. Here's what we now get. So all of the original data that was in flights 2, but an additional set of data that came from airlines with the name of the airlines. So what we just did is called a mutating join because it added a new variable to the data set. So let's look at some other examples. Here I'm going to do a natural join. The join is based on matching all the variables that appear in both data sets. So first thing I'm going to do is take time hour out of the weather data. It's a special type of data set and there's more to learn about it. So let's not even use it in the match. It's a special kind of date format that we haven't had time to learn about. So I'm going to take that out. What I'm going to do is I'm going to take flights 2. Remember what it looks like. I'll show you again. Flights 2. And I notice I did not add the carrier airline name because I didn't save that. So here it is, flights 2, this reduced set of variables. And I'm now going to left join it with weather, which means I'm going to keep all these. And what will weather use to do its match? Well, I didn't indicate. Notice the difference between this left join statement right here and the one up here. Up here, I told it to use carrier as the key. Here I'm not telling it to use any key. It is still a left join. It's still an outer join, but it's a natural outer join. What's it going to use as the key? It's going to look at all these variables. It's going to find which ones are available in the weather data set, and it's going to match up those variables that appear in both data sets. I think the weather data set might be too big for us to see what all is there, but let's take a look. Well, not too much. It says one more variable, so let's do that again. Okay, so you can already see if I go back up here to the flights data, year, month, day, hour, origin, destination, tail number, carrier. Here it looks like we have origin, year, month, day. Is that the only ones I had up here? And hour. Okay, so this down here does not have, the flights data has destination, tail number, and carrier. And of course, that is not going to be in the weather data, what your destination is. We don't specify the destination for the weather unless we're actually predicting weather and talking about where the storm is going next. So here we have origin, year, month, day, hour. Those are going to be matched up in this natural join. Why natural? Because I did not specify a key. So here it goes. Let me go ahead and open this a little bit bigger, and let's do the run. So notice that we do have destination, we do have tail number and carrier in this data set. Why? Because we did a left join, so everything in flights 2 was retained, but anytime we could find a match based upon that year, month, day, hour, and origin, then the temperature, the dew point, the humidity, and all of that was added as well. Pretty cool, huh? So another example. In this example, we'll put the information about planes with the flight information. Note that a natural join would match on both tail number and year, but we don't want that because the year in the flight's information is for the year of the flight, and the year in the plane's information is the year of the manufacturer. So you have to be careful about that. You have to be careful about natural joins. That's why I typically like to specify my variables with my joins. If I were just to do a natural join, it's going to match up on tail number because that appears in both flights and planes, and it's going to match up on year. But what you're probably going to end up with is no matches at all because those planes were all built in earlier years and the flights all have a specific year in them. So the year means different things. So we only want to join by tail number. So rather than a natural join, I'm doing a left join where I'm specifying how we want to match. So let me go ahead and run this. And there we go. So we have now the flight information as well as information about the airplane that's making the flight, how many seats it has, and so forth. Note that a suffix was added to each year variable to distinguish them. Ah, yes. Look at this. Even though we did not match on years, it now is going to identify them as two different variables, which is exactly what we want to have happen. We want them to be thought of as two because this is the year of manufacture. This is the year of the flight. So notice that R was smart enough to create two separate year variables because we did not match on them and want to match on them. It considered, hey, those must be two variables. And later on, we could come along and rename this to be flight year and this to be manufacturer year. Let's load the airport's data to illustrate joining when the variables we want to match don't have the same name. So we may still want to be looking for a match, but not necessarily on variables with the same name. Our two data sets may have different names. So I'm going to load this airport's data, and again, I have to, excuse me a minute, I have to tell it where it is in my file structure. Okay, so we've loaded the airports data, and so we have an FAA code. And that's the airports code listed in the airports data as an FAA code, but it's listed as a destination in the flights data. So here's how I can identify that. I can left join, and I indicate that I want my destination in the flights data, that comes first, to equal my FAA that's in the airports data, and I want to retain all the flights information. So let me go ahead and run that. And here we go. So we now have matched based upon this destination. Notice here we have now name, latitude, longitude, altitude, so forth. That all came from the airports data. It's giving us information about the airports that are our destination. And so you can see how very useful that could be. And we didn't have to have the same name within the same data sets. Okay, that's it for mutating joins. In the next section, I'll talk a little bit about filtering joins.